Electricity is amazing. It lights our homes, powers our devices, and even helps our bodies function. But electricity can also be dangerous if not handled properly. That's why we need to understand electrical safety. Electrical safety is all about using electricity in a way that prevents shocks, fires, and other hazards. One of the most important aspects of electrical safety is using the right components to control and protect our electrical systems. Just like we have traffic lights to control the flow of cars, we have electrical components that control the flow of electricity. These components help ensure that electricity flows where it's supposed to, and they interrupt the flow if there's a problem. In the following sections, we'll explore some of the key electrical components that keep us safe and make our electrical systems work smoothly. Get ready to learn about circuit breakers, resistors, capacitors, and more. Imagine a water pipe suddenly bursting. Water would spray everywhere, causing a huge mess. Circuit breakers act like safety valves for our electrical systems. They prevent dangerous overloads and short circuits. A circuit breaker is designed to interrupt the flow of electricity if it detects a fault. This prevents damage to your appliances and wiring, and most importantly, protects you from electrical shocks. You can usually find circuit breakers in a metal box called a breaker panel. Each breaker controls a specific circuit in your home, like the lights in your bedroom or the outlets in your kitchen. When a circuit breaker trips, it's like flipping a switch to the off position. This cuts off the electricity to that circuit, preventing further problems. Once the issue is resolved, you can usually reset the breaker by flipping the switch back to the on position. Just like there are different types of cars for different purposes, there are different types of circuit breakers designed for specific applications. Let's break down a few of the most common ones. RCBO, or residual current circuit breaker, with overcurrent protection, is like a super sensitive circuit breaker. It not only protects against overloads and short circuits, but also detects tiny electrical leaks that could be dangerous. MCB, or miniature circuit breaker, is the most common breaker found in homes. MCBs protect against overloads and short circuits. They are smaller than older types of breakers, making them more compact and easier to install. MCCB, or molded case circuit breaker, is a heavy-duty breaker used in industrial settings and large buildings. They can handle much higher currents than MCBs and often have adjustable trip settings. CB, or circuit breaker, is a general term for any device that interrupts the flow of electricity in a circuit. It encompasses all the specific types we've discussed. RCD, or residual current device, is similar to RCBOs and is highly sensitive to electrical leaks. They are often used as a backup safety measure in addition to circuit breakers. Resistors and capacitors are like the unsung heroes of the electrical world. They might be small, but they play a crucial role in controlling the flow of electricity in circuits. Resistors are like a narrow section in a water pipe that restricts the flow of water. That's similar to what a resistor does in an electrical circuit. Resistors limit the flow of current, which is important for protecting sensitive components and ensuring circuits operate correctly. Capacitors, on the other hand, are like a small, rechargeable battery. They store electrical energy and can release it quickly when needed. Capacitors are used in various applications, such as smoothing out voltage fluctuations and filtering out unwanted signals. By carefully selecting and combining resistors and capacitors, engineers can fine-tune the behavior of electrical circuits, making them work reliably and efficiently. Section 5. Fuses, the safety sacrifice. Fuses are like the self-sacrificing heroes of the electrical world. They protect circuits by burning out when there's an overload or short circuit. Imagine a thin wire inside a glass tube. That's essentially what a fuse is. When too much current flows through the wire, it gets hot and melts, breaking the circuit and stopping the flow of electricity. Fuses are simple and inexpensive, but they need to be replaced once they blow. While they might seem old-fashioned compared to circuit breakers, they still play a vital role in many electrical devices and systems. Section 6. Contactors and relays, electrical switching masters. Contactors and relays are like electrical switches on steroids. They allow us to control high-power circuits remotely and automatically. Contactors. Imagine a giant switch that can handle hundreds or even thousands of amps of current. That's a contactor. They are commonly used in industrial settings to control motors, pumps, and other heavy-duty equipment. Relays are like miniature versions of contactors. They use a small amount of current to control a much larger current. Relays are often used in control systems, allowing signals from sensors or timers to activate larger electrical loads. Both contactors and relays rely on electromagnetism to open and close their contacts, making them highly reliable and versatile switching devices. Section 7 switches from on to off and everything in between. Switches are the most familiar electrical components we interact with daily. They allow us to turn things on and off with a simple flick of a finger. One-way switch. This is the most basic type of switch. It has two terminals and can either complete or break a circuit. Flipping the switch up turns the circuit on and flipping it down turns it off. Two-way switch. Also known as a three-way switch, this type has three terminals and is used to control a light or outlet from two locations. For example, you can have one switch at the top of the stairs and another at the bottom to control the hallway light. Intermediate switch. This type of switch is used in conjunction with two-way switches to control a light from three or more locations. They are often used in long hallways or staircases. Section 8. Building a safer electrical future. Understanding the basic electrical components discussed in this essay is essential for ensuring electrical safety and promoting efficient energy use. From circuit breakers that protect us from overloads to resistors and capacitors that fine-tune circuit behavior, each component plays a vital role. As technology continues to advance, we can expect to see even more innovative electrical components emerge, but the fundamental principles of electrical safety and the importance of using the right components for the job will remain constant. By continuing to learn about electricity and practicing safe electrical habits, we can create a brighter and more sustainable future powered by this amazing force of nature.